All right, what did we talk about in section 5.3 here? Well, we said an integer b is divisible by a non-zero integer a if and only if there exists an integer q such that b equals aq. We had other phrases and other notation related to that. So, quick review. B is divisible by a. We also said a divides b. That's in symbols. In words, it's a divides b. Another way to say it is b is a multiple of a. And go back to the first video for this section to look for the others. And you can also look in the textbook, which I highly, highly recommend. But again, this is the definition we keep applying. And this is the related notation. Again, notice the role that A and B each have. Second big fact, aside from that big theorem, is if I have an integer greater than 1, I call it prime if and only if its only divisors are plus or minus 1 and plus or minus n. If that's not true for n, we say n is composite. A proper divisor of a composite number satisfies the inequality 1 is less than d, which is less than n. Let's take a quick preview of the exercises. So one phrase that pops out at me when I'm looking at the first problem is use the definition of divisibility. Use only the definition of divisibility. And then number 2, well, these facts look kind of similar to ones that we saw in the theorem and ones that we saw in the example after the big theorem. Number 3, similar. Number 4, similar. So we're practicing with proofs using a very specific definition in different ways. Again, forwards and backwards. And then we have some more concrete, kind of more on the numerical side problems where we apply this knowledge. And then just to finish things off, to give you a little preview of what's coming next. The next section is going to be about greatest common divisors. And we're going to still learn some new terminology. And again, it might not seem very new. It might be something you've seen in the past in previous math classes. Or, some of the stuff you see in this chapter we saw earlier this semester. We're just maybe making it more formal, or we're just looking at it in a different way. This is what helps us solidify our understanding of different things. What I highly encourage you to do after you're trying the exercises in section 5.3 is to look ahead and read and start remembering definitions. The formal, precise definitions that are given for a lot of terms are written that way for a reason. It helps us to have a really solid theory. We don't want to build anything on shaky ground. We don't want to build it on whatever notation or whatever ideas that we think are the right ideas. Okay? So just taking a quick preview of the definitions here. We have two integers, a and b. There's no restrictions on a and b so far. An integer c not equal to 0 is called a common divisor or a common factor of a and b if that number c divides both a and b. So to understand what this first sentence says, you have to have mastered working with the definition of divides. Okay? If a and b are not both 0, then we can define something called the greatest common divisor, which is the largest common divisor of both a and b. This tells us that the GCD, the greatest common divisor of A and B, must be positive. And then there's a little example here. You can look ahead and get a feel for this definition. Okay, so we have level 1 definition exploration, and then level 2 coming up with examples.